So, what does it actually take to build an AI from the ground up? Well, today we're going to do just that. We're going to build a digital brain and teach it a very, very specific skill: how to look at a picture and recognize a cow. And that brings us to the big question. How do you teach a computer to tell the difference between a cow and a sheep? I mean, it sounds simple for us, right? But for a machine, it's a huge, huge challenge. It's not just about spotting horns or wool. It's about teaching a machine to turn a chaotic mess of pixels into a clear, understandable concept. So how do we actually pull that off?
You know, every great project needs a clear mission. And for our AI, the mission is pretty straightforward. Look at a photo of a farm animal and tell us with confidence exactly what it is. Is it a cow? Is it a pig? No guesswork allowed. Simple as that.
To make that happen, first we have to define its vocabulary. So our AI is going to learn to identify these 5 specific categories. These are the only words, so to speak, that it's going to know. Now, this seems simple enough, but teaching it what these words really mean, well, that's where the real fun begins. Okay, now for what is maybe the most critical step of all: the data. See, you can't teach a student without a textbook. And for our AI, that textbook is a massive collection of images. And just like any good textbook, it needs to be perfectly organized. So here's how we set up the AI's entire curriculum. We split our photo library into 3 really important piles. First, you've got the training set. This is the main textbook, with almost 5,000 images for the AI to study. Then you have the validation set. Think of these as the pop quizzes, to check if it's actually learning anything. And the test set? That's the final exam. Totally new images it has never, ever seen before. And just like a textbook needs consistent formatting on every page, every single one of our images has to be standardized. We convert them to grayscale. That way it focuses on shapes, not colors. We resize every single one to be identical, and then we normalize the pixel values. All of this forces our AI to ignore the little distractions and focus only on the core patterns that truly define each animal. All right, our textbook is ready to go. Now it's time for the really creative part. We get to design the AI's brain. And we're not just grabbing some off-the-shelf model. Nope, we're building a custom neural network designed specifically for this challenge. Now here's the cool part. Our model isn't just one simple network. It's a hybrid. It's a really powerful combination of 2 different kinds of AI designed to work together perfectly. So the first part is a convolutional neural network, or a CNN. You can just think of this as the AI's eyes. It scans the image pixel by pixel, learning to spot the fundamental building blocks of what it's seeing. You know, the curve of a horn, the texture of a pig's snout, the sharp edge of a horse's leg. But, just spotting features isn't enough. You have to understand how they all fit together. And that's where the second part comes in, a recurrent neural network, or RNN. This part acts like the model's memory. It takes all those little features that the eye spotted and learns how they combine to form the complete picture of a cow instead of a horse. And this little line of code right here, this brings it all together. This is the official name on the blueprint for our unique creation. It's a CRNN, a convolutional recurrent neural network. This is the hybrid brain we've just designed from scratch. Okay, the brain is designed, the textbook is ready. Now, it's time to send our AI to school. The training process is basically a learning montage, where our model just studies the data over and over and over again, getting a little bit smarter with every single pass. In machine learning, one full pass through the entire training dataset is called an epoch. A simple way to think of it is like one academic year for our AI student, and we're going to put it through 25 of these school years. So after just 1 year of school, how did it do on its first quiz? Whoa, an 80% accuracy. That is an incredibly strong start. I mean, right out of the gate, it's already showing it has a pretty solid grasp of the basics. Now let's jump ahead to year 5. Look at that. The accuracy leaps to over 91%. The repetition is clearly paying off. Our model is really starting to refine its understanding, spotting all those subtle differences between each animal. And by the end of its 12th year, it's scoring nearly 94% on its quizzes. At this point, it's becoming a true expert. It's making fewer and fewer mistakes as it completely masters its subject material. All right, after 25 intense school years, it's finally time for the big one, the final exam. This is the real test. How is our model going to perform on data it has absolutely never seen before? This chart is basically the AI's entire school transcript. See the blue line on the left? That's its accuracy, just climbing steadily higher with each year. Now look at the orange line on the right. That represents its loss, or you could say its mistakes. See how it just keeps trending downward? This is the perfect picture of learning. Accuracy goes up, errors go down. Beautiful. And here it is, the final grade. On completely new images, our custom-built AI achieved an accuracy of 94.49%. That is a spectacular success. Our student has officially graduated with top honors. You know, we started this whole journey just by trying to teach a computer to see a cow. But what we've really built is a tool with absolutely incredible potential. An AI this accurate could totally revolutionize farming by monitoring livestock health, optimizing how a farm is managed, in ways we're probably just beginning to imagine. This isn't just a fun technical exercise, it's a real glimpse into the future of agriculture. So the real question is, what do we teach it to see next?